Hey Benji, I'm happy to move the defer stream stuff to the end of the agenda.
Thanks, Rob. I'm just doing that.
Just saw your message.
Done.
Hello.
Trying to get my headphones. Hey, there we go. We probably should have realized that this one fell on a holiday week and pushed it out by a week, which we I think did last year and then forgot to do this year. So I'm not surprised to see that we have a thinner crew, but thanks everybody for joining. Appreciating that tomorrow's a holiday for all the US folks. Our agenda pulled up. All right. 2, 3, 4, 5, 6, 7, 1, 2, 6. Yeah, good suggestion, Benji. Remind ourselves of the next upcoming dates. It's usually a good way for us to realize that we're about to land a date somewhere that doesn't quite make sense. I'm trying to see who from our, okay, I think Mark might join slightly later, but we will get kicked off with a quick round of intros, and then I'll dig into the agenda. We'll read them in the list in the agenda file, which I will post here in the notes, just in case. And I'll start at the top. Hello, everybody. My name is Lee.
Hey everyone, Rob from First Dibs.
I am going from memory. I think I was next. Hi, Jeff from Apollo.
Hi, folks. Benji from GraphQL.
Hey everyone, Mark from Yelp.
I'm from Apollo.
Matt from Meta.
I am Benoit from Apollo.
All right, thanks y'all for joining. Of course, by all of us being here, we agree to the spec membership agreement, participation guidelines, contribution guide, and code of conduct. Links for all of those things are in the doc. And we're recording the meeting today and creating summaries so we can post them. Quick run through of the agenda. We will take a quick look at the secondary agenda because a handful of folks did attend that. I think we have a dead link in the agenda file there, but I'll pull it up and post it here in the chat in a second. Actually, almost everybody here is there, not everyone. So we'll do a brief walkthrough of that. Anyhow, the rest of that is looking through a lot of our remaining pieces for the spec cut that's coming up. I'd love to talk about that for a minute. And Benji's going to take a few minutes to talk about an editorial change that he has queued up. And then we're going to go through a handful of our RFCs. We've got schema coordinates from Mark and Martine, course argument values from Benji, the list coercion algorithm also from Benji, and incorporating meta fields into execute collected fields. We'll do updates on defer and stream, and then we've got a couple discussion topics at the end, including removing fragment names and from visited fragments after visiting, and service capabilities syntax. That should probably keep us busy, but is there anything that anybody here wants to talk about today that we don't already have on our agenda? All right.
Just a quick shout
Um,
out that it's your last chance to get discounted tickets for GraphQL Conf. There's like 10 days left.
Yeah. We're making some noise about that too. Make sure you grab your ticket if you haven't. Okay, quick update from the last meeting, which we had, I believe, 2 weeks ago. Was sort of our overflow meeting from last time, which was fairly substantial. We made progress on schema coordinates, on Appendix C, which got merged. We did actually a bunch of merging. Descriptions on executable definitions, which was RFC2 with a few small tweaks. In the meantime, actually, that got finalized at 3 since we had decided in that meeting with like one criteria left, we would hit it to 3. That got merged. Defining execution result and request error result, also an editorial change which got merged. And deprecation on objects had a good discussion and talked about what we need to do next there. And then we had a bunch of RC discussions, including schema keyword, data collections, trilogy, pieces of that, which have gotten merged into the spec since, validation rules that operation types exist, of course, argument values has value, which we'll pick up again today, and list coercion algorithms. So we covered a ton of stuff last meeting. If you want to look back at any of that, please do, because we've been making a lot of progress on the draft spec. All right, with that kind of summary summed up, let's jump into today's pieces. Benji, you want to kick things off with defining execution?
Yes, I absolutely do. Sorry. Yes, so Lee and I have discussed this a little bit already, but I wanted to bring it back to the group because we did make some changes over the previous discussions here. So whilst trying to nail down all the terminology around this, what I ultimately concluded is that there is actually a clear separation between where request errors can occur and where execution errors can occur. And it is essentially the heading in the spec, which is executing operations. So to clarify, what I'm proposing in this pull request now is that we just change the word execution to operation execution in the relevant places throughout the spec where that definition makes a difference. And that way it clarifies that request execution covers the whole execution of the request, whereas the operation execution is the subset of that that specifically relates to, executing the selection sets. Algorithmically, this hasn't really had much of a change at all, with the exception of subscriptions, where I've hoisted the creation of the source event stream into execute request. So it's explicitly been hoisted out from subscribe where it was before. The reason for that is if the creation of the source event stream fails, then that should produce a request error, not an execution error. So we establish the source stream up front for a subscription, and then we move on to subscribe to that source stream. Other than that, all the algorithms are essentially unmodified, and it's just editorial. I've put in a few notes for clarity and revised a bit of wording throughout. But broadly, I think this makes it a lot clearer where the definition is, where the line is between those two types of errors.
I encourage folks to go read this one. Benji, some of your changes are late breaking, so I haven't reviewed all of them yet. Only one piece left on this that feels suspect to me is the lifting pieces of how to manage subscriptions up into the definition of execute request. That creating a source stream seems like a low-level detail that's very specific to how subscriptions work, which seems out of place when we're talking about executing a request.
Yeah,
That said,
I
subscriptions are weird for lots of reasons, so
yeah, I did consider creating a new algorithm for that, like a subscribe algorithm that happens during effectively execute request, which then would move on to like execute subscription or something like that. But in the end, this change seemed cleaner, and using effectively that guide of what type of error would this produce did say that this is where the line in the sand is. So the establishing of the source event stream does happen before execution.
yeah. It seems either way, we have to do some kind of special casing for subscriptions. My suggestion would just be in this explanation where we describe the definition of an operation execution, we can be clear that it has a slightly more nuanced boundary for subscriptions. Because even then, there's more oddities of how subscriptions work with respect to this, right?
Not with
The
regard
actual-
to errors, I don't think, because they will yield an event stream, essentially. So once you've got the source stream, you will return an event stream.
Right. Okay, I'll have to think about that one a little bit more. I'm not convinced that we want to separate subscriptions out to the top level like that. And subscriptions has this extra phase to execution that we haven't like fully described here, right? Like typical operations is, as you were framing it, the sort of like preamble to execution where we kind of frame up all the variables necessary and then the actual operation execution. But subscription has this like extra step in the middle where we are initializing the stream, source stream, which is like a very subscription specific thing. It is also kind of preamble-y, but it's different from the other preamble that we do.
Yeah, that's definitely correct. I mean, if you think about it from a GraphQL JS point of view, like this is done during the call to the subscribe method, which is a user-defined function. So
Right.
there is a bit here where is that part of so-called execution or not? And essentially, no. That's why it's called subscribe rather than resolve. But it is also, I understand, it is like in like a no man's land between the request execution and the execution, the operation execution. So maybe it does make sense to introduce a new algorithm specifically for that one step. But I think at the moment, how I've proposed it is actually it's a very clean separation of the request phase to the execution phase. And yes,
Yeah.
subscriptions are a little bit weird in that they call user code during the request phase. So yeah, I understand the concern, but this is currently my preferred solution. I don't have an alternative to it.
Okay. All right, let me think about this one a little bit more, but this one is much, much cleaner than it was a week or so ago. So awesome work.
Cool, thanks.
Mark and Martine, let's talk about schema coordinates.
Yeah, thanks, Lee. So apologies, I didn't get a chance to look at this properly with the video playback, which I was kind of hoping to do to make sure I had the context fresh in my head. But I took a stab at it from memory, and then Benji kind of sort of came in and helped clean up a little bit, or a lot. Anyway, so yeah, I think it came down to the ambiguity for we can resolve or we can't resolve meta fields. So let me just move out of the way where it's a bit less noisy. Yeah, we can't resolve meta fields for implementations where they didn't exist uniquely, because they're sort of like virtual objects. So the suggested solution was to sort of draw a ring around that and say this is undefined behavior, like the implementation can decide what to do there. That's what I've done. There's been no GraphQL JS implementation updates, because maybe that falls into the implementation specific behavior. But yeah, that's kind of, yeah, again, I think I'm happy with it from my end now. So I cede it back to you all to consider. Martin, anything else to add?
Not that much. I think that since, I mean, I had one question actually. Since a lot of the questions is about the resolving logic, would it help if we didn't specify resolving at all? Like we just go for the syntax because this is what people use, and we just skip all the resolve stuff. Would that make it easier to make it in 2 steps? And it still preserves option value, right? Like we can introduce the algorithm in the next spec release in 1 year or something like that. So this was my big question for today. So maybe I'm going to remote in direction.
I mean, I'll obviously let other people answer, but I feel like if what we've proposed right now people are okay with and are happy with, and
Yes,
which there may indeed be, then
yes.
we don't need to do that. So yeah, Benji just says I think what we have spec-wise is good to go. So yeah, I'm happy with it. Benji's happy with it. So
If we all agree, then yes, perfect. Ship it.
I think so. I mean, I might go through and like tweak some of the language a bit just to try to make this meta case slightly more clear, but I think the rules that you guys have set up, I agree with. I don't think we have to go as far as like stripping any of the pieces out. I think it's pretty valuable to say not just here's the syntax, but like here's the semantics of what that syntax means. The thing that I was trying to say last meeting, which I'll just repeat for posterity, is it's one thing to say that like such a thing is syntactically valid, and it's another thing to say that this syntactically valid thing resolves to something. Like there's this like very specific step of resolving the coordinate. And I think where we've netted out is that you can syntactically write a schema coordinate, which includes something meta, it includes a double underscore. It's just not resolvable. Like you can't resolve that to something in your schema because like those are just kind of like special markers that we handle, and they don't actually map to a type or a field. Although that's actually not true for, well, I guess it's true for the top level ones too. So I think this note is probably the right thing, that we can just sort of like leave it implementation defined, but to say like they're not going to come from your schema.
Implementation defined feels, I don't know. I guess if we use that terminology elsewhere in the spec, then I guess it's fine. But feels a little terse, I guess, that phrasing, like left to the implementation to decide or something like that. It feels a bit inscrutable. Maybe I'm being nitpicky. Anyway.
No, it's a good
cool.
nitpick. It's a good nitpick.
So then I guess the next steps are to, yeah, Benji says update the JS version. So the JS version does something right now. I think it does return the virtual objects. So I don't know if that needs updating or not. So I'm curious to get more context there, Benji. And then kind of maybe a round of another round of review there, just with it in its the spec in its final state. Yeah, and anything else?
I think that's good. I mean, I certainly like that. That is the difference between saying that a meta field is not resolvable versus if it's a meta field, then it's going to be implementation defined. And I agree with your saying it's like a little bit too terse, and we should be a little bit more clear about why that's the case. But that would be the difference for the GraphQL JS implementation. Like it would be weird to say this is not resolvable in the spec, or not just weird, it'd be non-compliant to say like it does not resolve in the spec, and then in GraphQL JS it actually does resolve, and it resolves to this like thing that's not accurately described the behavior of in the spec. And so I think like to say, meta fields don't resolve to something in your schema, but we leave it up to the implementation to decide if that's like a thing that they want to support directly. Like it is both spec compliant to say it does not resolve, and it is also spec compliant to say like it resolves to this like weird dynamic thing that we've created.
Yeah, I formally take back my little comment there. The one that Benji posted directly above schema element and therefore resolving such coordinates results in results in undefined behavior or results in behavior that can whatever. Anyway, but yeah, basically something like that is good. So okay, so I'm happy. So then I guess yeah, I'll speak to Benji about whatever we need to do for the JS version. I'm quite sure there. And then
Yeah, what's the current state of GraphQL JS with respect to this?
I believe that it will return you the virtual object. So it will resolve the global instance if you do under type name.
I think as long as our kind of final decision here is that this is an implementation, like meta field resolution is implementation specific,
Right.
then it's fine to just leave that as is. And if everyone is like cool with that behavior, because it's like the balance between being useful. I think maybe the other thing would be, this is not necessarily a proposal, but just tossing it out for discussion is like if that function on GraphQL JS takes an argument where you have to opt into that behavior, like by default, it doesn't resolve to anything, but you can like pass a, resolve meta fields true kind of, optional thing. And if that's the case, then it gives you back the dynamic thing. I don't know if that's better or worse. It certainly makes the default case do only your schema, but like maybe that's not exactly what you expect. My sense is like the vast majority of people who are using this functionality are tool builders and not like end consumers. And so, our like level of scrutiny for that should be slightly lower because we would assume like more knowledgeable people are doing tool building, and probably want this kind of like language specific or implementation specific behavior.
That makes sense.
So on the GraphQL JS front, I think the only thing pending, and I haven't looked at the code, so I don't remember for sure, is that all of the different schema elements have like a to schema coordinate method, and that should throw an error or return null or something like that on meta fields, because there is not a schema coordinate. They do not know what their schema coordinate is. Like it's never going to be user.dunder type name, for example.
Right. Well, I wonder what it does right now, actually.
I have a vague feeling that it returns like triangular brackets meta.dunder type name, and we definitely don't want it to do that.
Yeah.
Okay. So I can,
Yeah.
we can add that restriction. That makes sense. Okay, I will try and get that PR in today, right now, basically. And so then my next question, annoying as it definitely is, I'm aware that the cutoff for the spec was July 1st, but What do we think?
It was like kind of the week of July 1st. So basically it's saying, you know, if we don't get everything in time, then we won't be on time for the rest of our timeline. But we have not cut the spec yet. So I think this one's on the fence post for getting in before we cut. And I think we're now in a state, like I need to do a final editorial review, but this is in line with GraphQL JS, aside from the like last fiddly bits of meta fields. The major stuff has been merged, you know, as of, you know, a couple weeks ago. So I think we're good. I think we're RC3. Am I missing anything?
I think spec-wise
Cool.
we're happy, but we need the GraphQL JS to mirror it just for us to have absolute confidence. But I think we are pretty close to RFC3. 2.9.
Yeah, I'm gonna mark it as 3 since the parts of GraphQL JS that need changing are the parts in the spec that we've said are implementation specific. So I think that like a kind of we're threading the needle a little bit here, but I think it like lands us in a state where we say actually the specification covered surface area of GraphQL JS is compliant. It's just that we have slightly odd behavior on the meta fields front. And you know, we want to make sure that the ergonomics of that function GraphQL JS are good. But I don't think that necessarily blocks the spec. Is that right? Or is there actually something on the like normative compliance front that I'm missing here?
I can't confirm for definite, but I think we're okay by having effectively scoped that area out.
And
Yeah.
I'm going to try and get that PR in to close the loop that Benji was saying before the end of this meeting. So we'll see if that happens.
I'm just
Cool.
aware that it wasn't until we were updating that pull request that we realized why it was that you'd effectively ruled out meta fields in the first place. So there could be something hiding there, is my concern.
It's
But I
also
think
like
it's
part of the
probably fine.
reason, yeah, part of the reason why that's implementation specific. I think I'm gonna go back through with sort of my editorial comb, and like part of what I will make clear in that note is a meta field never resolves to something in your schema, because meta fields are not part of your schema. However, if an implementation wishes to present like an implementation specific like characterization of a thing, like if the definition of resolve this relative to my schema, like that will always be null. But like if an implementation wants to do something where it's going to like help you get access to meta fields, like that's fine. That doesn't break spec compliance. That's like just a separate behavior. And then similarly, you know, saying everything in your schema has a schema coordinate remains true because meta fields are not in your schema. And so, you know, it's actually just like a GraphQL JS quirk that the like double underscore, you know, type name dynamic field happens to be a global singleton. Like that was a convenience thing because never before have we needed to have a unique one for every type. But you could certainly imagine some other implementation didn't make that choice. They didn't make it a global singleton. There actually is a unique instance per type, in which case, like they would never be having this conversation in the first place, because they could just say like individual instance that we created for this type, what's your schema coordinate, and it would just work. So hence why a lot of the stuff is just going to be implementation specific, and that's fine.
Just a small like extension on that. The meta fields aren't part of your schema, but I think also the introspection schema is not either. And that's something that we need to call out. Effectively, you can't get to the introspection schema without going through a meta field. So that is kind of the separation. And even in the spec, we describe the introspection schema as also being a GraphQL schema. The reason that I wanted to call this out specifically is because if you do go into introspection and you ask, hey, what are the types in my schema types name, it will give you both the types in your schema and the introspection types. So the introspection query is essentially saying these are all part of your schema. but they're not really, right? The dunder prefixed ones aren't part of your schema. They're part of like the GraphQL schema of the implementation, the introspection schema. So I tried to add some sort of clarifying notes around that, but yeah, when you're going over it in your editorial pass, please keep that subtlety in mind as well, please. Thanks.
Nice. Okay.
Sorry, one more. I'm going to be super annoying, Benji. The thing you were just talking about earlier about nodes having like a dot coordinate field to return you the schema coordinate. Maybe I'm losing my mind or something, but I remember that being implemented kind of in this PR, but this is not like the official mainline Lee original author PR. So that method does not exist that I can find.
Okay, chat to me about it afterwards, Mark, because I'll need to look it up.
Sure.
Cool. Thanks for that pointer. All right, nice work. We can always, you know, extend from here, but I think we've got our solid base for having defined schema coordinates. And where did my agenda file go? Okay, awesome. Benji, you are up next with course argument values.
Okay, so I'm going to be quite quick on these two. I brought them up, I think, at the last working group, but forgot to get them processed through the RFC system. So they are both still RFC 1. They are the behavior of GraphQL.js currently. So both of them, let's look at them one at a time. So the coerce argument values has value. Yovi has confirmed that this looks in line with what GraphQL.js does. So I believe it matches the criteria for RFC 2. So I'd just like to advance that if we are happy to do so.
I'm happy to advance this. However, I also have a suggestion to take on a slightly bolder change. And we can do those in parallel. I think the bolder one can just completely supplant this in the long term. I dropped a comment onto that PR with a link, but I'll post it here just for everyone. Basically to kind of like reframe this entire algorithm to not have to rely on a has value in the first place, which in my opinion was like the true root issue for why we ended up in the kind of root bug that you described, where you have the sort of like accessing a variable that hasn't been defined, null pointer exception kind of thing. Which I think only exists because we were like separately tracking assigning variables from like this other Boolean where we decide if that variable had been assigned. That's like very strange. It's the only place in the spec that we do that. And I think it was just like a rhetorical trick to try to avoid duplication. And my sense was instead we could just do kind of the standard rules that all the other algorithms do, which is, you know, if something is defined, then, and then you kind of like, you know, indent in, and then you like know that that thing definitely is defined in the scope of that condition.
I like the look of this algorithm better. Obviously, I'll need to read it to make sure that it like is all correct and everything. But yeah, I do like this fix better.
And then this is yet another one slight, you know, if your suggested change is a baby step, then mine is a slightly bigger step. And I think like the actual thing that we should really be doing, that's a much bigger piece of work, is to kind of go through and more formally define how input coercion works overall, because there is nowhere in the spec where we define input objects and variables embedded within them and the like various rules of exactly what happens in all of those cases. GraphQL.js does a good job of doing that, and there's a whole bunch of unit tests to make sure that it works correctly. But like the closest we get is in the input objects section. We just, you know, have an input coercion section where we list out like a handful of rules. And it is definitely underdefined.
Agree. And that brings me to my second one, which is the coercion for the arrays.
Yay.
So again, this mirrors what GraphQL.js does, as confirmed by Yovi. This one is also in line with GraphQL.js. We deeply traverse and perform the same logic as during normal coercion on each value we find deeply. So he has confirmed that that aligns with this change. And this change, like you say, the input objects actually isn't terrible. Like it could definitely be improved. But the list coercion didn't even mention variables. Like it's a whole really, really, really massively underspecified part. And that did actually lead to some bugs in an implementation like a few years back as well. I do not recall what it was because this has been open for a little while now. But yeah, so this essentially, as you know, adds a coercion table, much like the input objects one, that gives you the variable values and what the result of that is, and shows you what the difference is with the different expected types based on nullability as well, and also introduces a couple of algorithms that you can use to follow to understand how that works. And if we like this change, we can then backport it a bit into the input coercion. Lee, I'm aware that you're, I think some of the wording in this might have been a little wordy for you, which is, you know, I often do things a little too wordy. So we can cut that down, but I think it probably still meets the criteria for RFC 2. So I suggest that we advance it to there, and then we can look at addressing the rest of it later.
Okay, let me toss out a suggestion to see if folks agree. My suggestion is that we do not advance to stage 2, which would imply a fully formed solution. That, you know, there's still, perhaps there's details to do in GraphQL.js, or we're going to continue to fiddle with the spec text to get it editorialized into the right state. But my proposal would be actually, I think we should adopt the entire problem domain of input coercion being underdefined in the spec and like solve it holistically, because I think this is at stage 2 specifically for list coercion, but we also haven't defined input or input object coercion. And rather than doing these piecemeal sort of one type at a time, I think we might end up at a cleaner solution if we just like take a big step back and say, actually, the entire domain of input coercion is underdefined and hard to understand, and that's actually the problem scope that we should be addressing, in which case then we probably shouldn't make the case for stage 2 because there's big chunks of it that still feel not finished.
So my main hesitation with that is it's underspecified right now. Anyone who wants to build a new implementation of GraphQL is working with an underspecified thing, and it's better to get something that's more specified out and then do the other stuff in a follow-up work. I agree that we could refactor the lot in a consistent way, but there's no reason we couldn't do that as well as a second step, like refactor this if there turns out to be like shared utilities we can use between them and stuff. this is a weird section that has caused problems in implementations before. And I have heard that there are other people, like there was someone who was interested in making a C implementation of GraphQL. So basically, whenever there's a bug in the spec or like a massive gap in the writing for it, especially if they don't want to just copy GraphQL.js, I feel like we should just get a fix in and then solve the overarching problem later. Like prioritize it, but like get something out there for now.
Let me pull this one up again. I'm just seeing Matt's comment. Okay, I'm aligned with this approach, which is essentially like I'll read this more carefully. I think I trust you that this probably is covering our bases and is RFC2, but it probably behooves us to get a couple more eyeballs on it just to make sure that we haven't missed anything in this more clear definition. And otherwise, like I'm cool saying this is at draft phase for specifically lists. And then in addition, I would like to race another set of proposals that go through and try to do this more holistically. And if we're able to do that, then we should essentially consider this one, RFCX, what was your term, replaced or
superseded?
Superseded, yeah. My hope is that we go for superseding this one with one that can actually just address the whole input type coercion. And if that one ends up being a boondoggle and what has like a lot of hard pieces that we need to get right, then great, like we can make incremental progress in the meantime. But I'm feeling optimistic that we can get a superseding, slightly larger scoped change up and running decently quickly.
Does the shape of the solution look roughly right? Like, because if we're gonna expand it to other sections of the spec as well, it would be frustrating to do a lot of similar work and then find that it wasn't quite the right approach. We don't want that style of algorithm here or whatever.
At current read, I think so. My assumption of what that might look like is to just take inspiration from how we do value completion, because value completion is essentially the dual of this, right? Because we have some internal domain value that then needs to be coerced into a value that aligns to the output type definition. And that algorithm is well detailed and handles lists and non-nulls and input objects and the rest, or at least I believe it does. I certainly hope it does. And presumably we would do something similar. Oh, I guess input objects is a special case where it's input only, which is certainly going to make things more complicated. But for output type for value completion, we handle lists and things as part of that. So I guess like probably the one major open question, which would be the only thing I don't think it blocks RFC2, but worth considering is where this stuff lives. Do we want to have it be part of the type definition itself, which is in that like type system part of the language, or is it actually part of execution? Right now, it's like a little bit smushed between the two.
We do have, and this is the other issue I wanted to raise, is essentially like this section of the spec is used both during validation and during execution. And during validation, the variables are sort of like assumed to be fine, because we've got validation rules that say you can only use them in valid locations and stuff.
Yeah.
But then at runtime, we actually have to coerce the actual values. So we're mixing literals with variables and so on. And that is like we don't deal with that dance very well in this section, in my opinion. And this section is also very prose based. It's not very algorithmic in most cases. There are algorithms, but they're few and far between. Which is why I was wondering whether the more algorithmic approach is the sort of right style of approach.
The algorithmic approach should almost always be the right. It's just much more clear, right? Like we define them very crisply in terms of like executable logic, which is just always going to be easier to understand than English prose alone. Okay, I'm a fan of what Matt said in the comments here, which is we're RFC2ing this. There's probably more editorial tweaks that we need to do. I can't imagine a world where like we wildly change these algorithms because they accurately describe what happens today, or at least are pretty damn close to it. And then we try to beat it with the holistic refactor, which will allow us to supplant it. Thanks for getting this put
Sounds
together.
good.
This is I'm glad that we are circling around this problem.
For the has value, do you think it's worth just merging that into this spec release? Because it is like a long-standing bug in the spec, essentially.
I think so. So we're marking this as an actual RFC rather than an editorial change because conceivably, technically, it's changing the behavior. Or is this actually an editorial change where the spec text was
The spec
underdefined and
text,
faulty?
the spec text was faulty, but anyone who has implemented the spec text will have bugs in their implementation, which presumably they would have discovered by now.
Yeah.
So yeah, I wasn't quite sure. It's not 100% clearly an editorial change, but it is just a fix to essentially a mistake in the algorithm.
Cool. Yeah, this one, I mean, the other ones are about places where we underdefine or are ambiguous, providing more crisp definition, which is always a good thing. However, this very specific has value one is like actively wrong, which feels more urgent. Like I'd rather get that one completed and merged while we do the remaining work of being more clear. But fixing active bugs seems much higher priority. So I'm gonna mark that one as an accepted change. I think it's probably the right call to have marked that as an RFC rather than editorial, since it actually is changing behavior in a subtle way.
Cool, agreed.
Cool. Okay, I will actually I'm just gonna go ahead and merge that one since there's not much follow-up work to do there. So we've officially fixed in the spec the has value bug, and then we will continue the work on clarifying the rest of it. Awesome. Thank you for your work on that. That was a great one. All right, should we talk about the execute collected fields? Maybe for some context before we dive into this next one. We've had some discussion over the last handful of meetings about clarifying the actual, like we say, execute selection sets. And a selection set is not actually a thing you can execute because it has to go through this sort of like collection phase. And Benji's done a ton of great work to tease out much more clear definitions of the two phases that occur, and then throughout all the places in the spec we'll refer to that, referring to them very clearly as the collection phase and then the execution phase, which is awesome. It's like a much better description of exactly what's going on in a GraphQL engine. And over the last, I think literally just over the course of this week, Benji and I iterated towards a final version of that where we actually renamed a decent amount of things. And so before there was variable names floating around called grouped fields, which also bothered me a lot because we had a concept of a collecting and then also a concept of a group rather than a collection. So we also just sort of did like a naming cleanup along the way. That was a relatively substantial change. So I would suggest folks like go check that out. That's essentially a prerequisite for like much more deeply understanding the rest of this work that we're digging into. But anyhow, that's an update. I'll try to dig through and find the specific PR which landed that real quick just to give you all something specific to grab onto. Here we go. It's 10:39.
And to add a little more context for this, for the incremental delivery folks and the fragment argument folks, this is the refactoring of those algorithms that we needed to make the implementation of those other pull requests easier. So that is now merged. So you should all rebase on that and it should make your pull requests a bit simpler.
Yeah, it's a pretty big change in terms of an editorial change. It is editorial. It doesn't change the behavior of GraphQL in any specific way, but it like moves sections around and it renames a handful of concepts and variables in such a way that if you do have work that's based on top of it, then Rob, especially thinking about you, then like making sure that you read through and understand that change first is really going to help you out when you go about doing rebasing. And then also if you're working on GraphQL JS or GraphQL Kotlin or any of the other implementations, it's probably worth like digging through and seeing if there's variable naming cleanup on the implementation side that can be inspired by this. That might also be a worthwhile thing to look into. So anyhow, I just want to draw a little bit of attention to that change. I'm a big fan of it, so thank you, Benji, for championing it. Okay, and with that said, we can dig into the next pieces, which is now work we can do on top of that. So Benji, go ahead and walk us through meta fields and execute collected fields.
Yeah, so last week, whilst we were talking about all this other stuff, you noticed, I think just out of the corner of your eye, that we don't seem to talk about meta fields here. Like, we don't talk about the execution of those. And yeah, the execution algorithms in the spec do not seem to have the ability to execute meta fields. We define them in the introspection section, but we don't tell you how to execute them. And if you follow the spec execution rules tightly, they are not fields of the underlying type, and so they don't exist, and so you don't execute them, and so you don't add anything to the result map, and they just disappear, is technically what happens. So again, this is kind of a bug in the spec where we forgot to mention a thing. So I had to dig through what we do in GraphQL JS. And in there, we have a helper function called getFieldDef, where you essentially give it an object type and a field name, and it will return the field definition for you, which isn't necessarily a field of that type because it could be one of our meta fields. So it will return the Dunder type name or the Dunder schema or the Dunder type, depending on what the relevant thing is. So I've essentially backported that change into the spec. Now, the interesting thing there is in GraphQL JS, they do it inside of the execute field method, which does not already have a resolved field type, unlike the execute field algorithm in the spec, which does. So essentially, the logic happens in slightly different places. And in GraphQL JS, we return undefined if it's a thing that we can't do. And then the higher up algorithm says, if it's undefined, don't add anything. But like if it's null, go ahead and add a thing. We don't want to do that in the spec. We don't want to deal with null and undefined as JavaScript madness. So in the GraphQL spec, I've effectively hoisted this up into the the parent algorithm, which is execute collected fields. But essentially, it does the same thing. It says, if the field name that we're meant to be executing is a meta field, then go and do the stuff it tells you in the introspection schema section, sorry. Otherwise, do the normal field execution stuff. I haven't gone any deeper than that. I think that's probably sufficient. What do you think, Lee?
Yeah, I think this maps very tightly to what happens in GraphQL.js, while, to your point, avoiding the madness of a value being defined or not being weird in JavaScript. I think this is a great change. This feels like similar to me in the same category of the last change we talked about, where it's one of those things which is like correctly implemented in all the implementations and just like strangely absent or incorrect in the spec. And therefore this like feels like a thing that we should be able to very rapidly move through the RFC phases. And having it here does seem like the right place. Like you could plausibly make the argument that execute field is the more appropriate place for it. But like to your point, like it's not actually a field getting executed. It is a meta field that has like specific behavior.
So originally I put this logic in the resolve field or whatever it is, where it actually calls the resolver.
Yeah.
But then when I trace through the algorithm, it would never get called because we have a check to see if the field type exists. And if it doesn't exist, we don't call it. And of course, because the field doesn't exist, because it's a meta field, it wouldn't happen. So this is the point, 584 in the deleted, where we actually were checking to see if this thing exists. So if we did want to push it lower, we would have to effectively pass more stuff through to the next layer. So yeah, it did feel like the right place. Matt?
Yeah, the place feels right to me. The only thing that is like algorithmically is a meta field as defined in the introspection section, like does it make sense to like essentially have a set of those fields or a like map of field to or some like I'm fine actually with this ending up in the spec as is, but that specifically feels like okay, do we just have like a global static thing? Is there a function for is meta field? Is there I don't know. But that's very, very nitpicky.
So when I first wrote this, as everything I write, it had more words. And the more words included like dunder type name, dunder schema, dunder whatever. And what I realized is just because it starts with dunder doesn't mean that it is a meta field. For example, user.dunder schema is not a meta field because that doesn't exist, right? The dunder schema only exists on the root query type. So as I started to add text that explains that, I was like, nah, this is already explained in. So I trimmed all that out, and that was the logic behind the simpler form.
I like the simpler form, but as I'm like trying to understand, I was trying to decide if not being part of execute field, like how could that be a problem, if at all? And I actually think it is potentially a problem because if you think about this for double underscore type name, then this is sufficient because double underscore type name just returns a scalar string for the type name. And so therefore saying, let this be the result of resolving that meta field. We do a little hand wave and it's like, great, it's a string value. Like that's clear enough. But what if it's double underscore schema or double underscore type, which returns you back like actually a real type that we define? in the schema, and then at that point you have an object, and like you're back to like regular GraphQL execution. At that point, you're just using types defined in the schema, or types defined in the spec instead of types defined in your personal schema.
Yeah,
Like it bypasses complete field, it bypasses all those other things. Like, is that,
I
are we
thought
just gonna
about
say
that
like that's
too.
fine?
I think so. So I originally was like, oh, let's have it just, return the schema like it would, and then do the regular execution, as you say.
Yeah.
But essentially, that is what the introspection section tells you to do. So you are essentially saying like, here are what the fields do, and it still follows the same kind of GraphQL execution. So you can see this as go and do the special introspection stuff. I haven't specifically called it as an algorithm, right? So essentially you have ambiently access to all of the same things that you would for normal execution. And then I imagine that as an implementation, you would then just go back to complete value, just like you would, or whichever algorithm it was that the next one would be. And then you just go back into the GraphQL flow, but it's sort of it's implicit rather than explicit. We could add an explicit form of it, but I think then we would need to make some of the introspections section of the spec a bit more like, here are the resolvers for this, this kind of thing, rather than I think it's a bit looser at the moment, which I think is fine, honestly. Otherwise, you need to decide, are you saying return the schema object, right? Is it an object in memory that represents the schema? Is that what you're returning, or what are you returning as a value here? Are you returning the field, the type, etc.? Which I think is essentially what we say you're doing, but that might not necessarily be, I don't know. It's probably fine. It's what GraphQL.js does, so. The other thing here is like, obviously this also accepts arguments, like the dunder type accepts the argument of the type name. So that's, again, implicit rather than explicit. We could make this more explicit. I'm not sure it warrants it. I think that would probably overcomplicate things, but like, happy to do so.
Yeah. What do we want to do here? All right, at a very minimum, this is at least RFC1, because I think it should be plainly obvious that this is a hole in the spec and therefore a problem we're solving, which is the only real criteria for RFC1 is that this is a problem we're solving. So I'm just going to go ahead and optimistically apply that. The question then is like, is this sort of like the final form? Is this sort of like absolute minimum form appropriate? Or yeah, Matt's mentioning sort of like the counter proposal in chat, which I think is closest to what I had in my mind, is like the slightly larger version. There's certainly like the largest possible version, which is a single algorithm which walks through all of the possible things that occur for every part of the introspection surface area, and that seems, to your point, Benji, probably overkill, and we already kind of do that in the introspection section.
We could
certainly
just define them for dunder type name, dunder schema, and dunder type, right? Here are the values that they return, and then it just goes back through the normal algorithm.
Right. Right. Yeah, because there's only 3 meta fields
currently.
And if there were new ones, presumably we'd want to define it. Anyway, okay, I think probably what we want to do here is I'm gonna leave this marked RFC1 for now, and the other plausible alternative candidate that would get to RFC2 is this sort of like slightly more spelled out version, which just sort of defines like, here's the 3 meta fields, here's what they do, and then like steps into a process from there. That feels like a thing we can figure out, and then like, I don't know, as soon as you or I get to kind of like drafting that up, and if we look at it and say, nah, this is way too complicated, then I really appreciate having the sort of minimal version, and we'll just like roll forward with that. And the nice thing is that once we get, like, I think this actually is just whichever the two we end up deciding is ideal, probably just jump straight to RFC3 because there's no GraphQL.js change necessary here. This is all just kind of closing the gap between the spec and the implementation. And so I don't think there's actually any headroom between RFC2 and RFC3 here. It's just like as soon as we figured out the one that is the appropriate draft, we will just essentially immediately approve it.
Sounds good. The only other thing is I think this has to be done in execute collected fields because
Yes.
there's no other way to skip over the key, right? We haven't got like another sentinel or whatever that we can return, unlike the undefined in GraphQL.js.
Yeah, no, that I agree. I think it's
Okay.
the I have too many tabs open. I'm like, where did it just go? Yeah, like I think it would literally just be this line 585 where it says let response value be the result of, and then we've got this like hand wavy prose, just like, yeah, refer to this other section. I think the alternative proposal would be essentially the like mirror of let response value be execute field, except execute meta field would obviously take slightly different arguments.
And should I make it so that execute meta field or whatever we call it belongs in the introspection section of the spec? It feels quite natural to move it there to me.
I think it's okay for it to be in execution because it's like executing the introspection. We like define how introspection works there, and then we execute it here. Like I think if it gets more than like a couple dozen lines of change at most, then that's a clear sign that it's getting too crazy and it's the wrong path. But
Okay.
if it is like for a little bit more lines, you sort of get like a much crisper definition of what happens for these things. And then obviously kind of wherever it lives, it should have, as you've done here, links back to the relevant places in introspection.
Do you think it's worth adding a is meta field algorithm?
Nah. No, I think what you said here, it's a meta field as defined in this spectrum is like enough because there's only 3 of them, and it's like it's either one of these 3 or it's not. that would be the entirety of that algorithm. It's like if it's this or this.
Cool. All good. Let's move on.
Cool. Yeah. Thanks for making progress on this one quickly. That's another great one for us to be solving. All right. Defer and stream. Rob, you want to catch us up to date with progress made?
Yeah. I have 2 topics. The first one I want to talk about, I'm going to share my screen. Did that work?
Yeah.
Yeah, okay. Yeah, so Yakov wrote up this great discussion about the return type of the execute function, specifically for GraphQL.js. But to summarize, this is in the version 17 alphas. And to be clear, the function is called experimental execute incrementally. So any changes there would not be affecting the code that people should not be expecting to be production ready. But yeah, so currently what we have is the return type of that function is either an execution result, which is the regular object that we know with data errors, etc., or another object that has two properties, the initial execution result and then subsequent results, which is a generator async interval of subsequent execution results. And so it's two different types where the initial execution result has the data and errors of your initial result with also the extra fields that we need for incremental delivery. And then the subsequent execution result is the fields for incremental delivery without data and errors and top level data and errors, I'll say. So this is an extra map that it's kind of like an extra level of indirection. What we could do also is return the execution result or return an async generator, where the first object you're going to get is the initial execution result, and then every other object after that is a subsequent execution results. This was proposed by David Glasser at Apollo. It kind of makes the type checking a bit easier. You can, I think maybe with TypeScript, it was kind of hard to tell between an object or a async generator. I think that's not the case anymore. And also, you can easily distinguish the types from the initial result and the subsequent results. The downside here that Benji raised is that if you consume this initial result and maybe you throw an error or maybe you just ignore subsequent results, you could have a memory leak from not consuming the async generator. With the proposed example, I'm not sure there's a good way to type that the generator is returning one object, but only the first one, and then everything else is different. So you probably need to do a type check on each iteration that you get back. So yeah, Benji, if you have anything else to add, let me know, or just want to open it up to the group and see what thoughts are.
I think you covered it well.
And then the questions that we could go into this are, is this wrapper object kind of an implementation detail? The spec is kind of written right now as you're returning a stream of these results. Should we mirror that? If we do decide to go with this wrapper object, should we mirror that in the spec? Or how closely should they match each other?
Certainly wouldn't be the only place in the spec where we under specify asynchronous behavior. My read is that this is an implementation detail and probably shouldn't change anything about the spec. Or maybe another way to say that is like if the spec is written in such a way that like deciding to have a promise of a generator as opposed to a generator where the first thing comes back, like if that implementation level detail results in something no longer being spec compliant, that probably means we need to further generalize the spec text to allow such variants to happen. Because this does seem implementation detail-y. That said, I like GraphQL.js's current data structure type. Like it makes sense to me that the first thing I would do is, request a result, and then I would get subsequent deltas after that as like a stream. And it also makes sense to me that if I was going to send this over HTTP, that HTTP does not have the concept of a promise or a generator. It just has a byte stream, and like this all has to get encoded there anyhow, in which case there's ways to define both of those two kinds of variants. Yeah, so I'm curious, like from a spec development point of view, um, Rob, where do you see this becoming tricky?
Um, I think that and I think that I would have in the response section of the spec, I'm going to define an incremental stream, and I'm going to say that the first thing you get is a initial execution results, and then every object after that is going to be every result after that is going to be a subsequent execution result. And I don't think I would go into more details about that. Um, I I certainly could. I could model this exactly and say that you're going to get an execution result, or you're going to get a map that has a key with the initial result and then a stream of that. But when that doesn't transfer well over to HTTP, like you said. So I I think saying just the stream is general enough that this is kind of an implementation detail, and it doesn't like exactly match up, but I mean, a generator is not the same, exactly the same as a stream anyway.
Yeah.
So
Here's the one case where I imagine it might influence spec text. Because anyhow, what you just said seems fine. Like I think if we wanted to specifically define the execution of a GraphQL operation as that GraphQL operation executing it gives you back a stream, and then you're gonna get like some sequence of results over that stream. Which in the common case is you'll get exactly one thing, and in the case that you've done defer or stream, then you'll get multiple things, or plausibly you could get multiple things before it completes. Um, and like maybe the place where we actually would want to make the spec text more similar to this sort of initial results, subsequent results thing is if we didn't want to change the base return type of execution. Currently, we say when you execute, you get a map, which is like kind of wrong because no implementation like that just reads as if it is synchronous, and it is not. It is asynchronous, right? Like you don't actually get a map. You get back either a promise of a map or a task that gives resolves to a map, all of which are abstractions that describe a stream of which there's only ever one, exactly one payload. And so, if we wanted to say during the course of executing a query, or an operation, you're going to get an initial result the same way you did before, and then also if anything was deferred and streamed, like here's this, delta stream that comes along with it, and then the expectation is that someone who's then like consuming this over HTTP or something like that is essentially going to like connect the dots together in much the same way that you would imagine someone using this TypeScript definition, where they would, emit their initial result over their HTTP connection, and then they would like wire up their async generator and emit those next. Which is why, like, as an implementation detail, like these are actually functionally equivalent from like an HTTP API consumer's point of view. Like they don't see promises or generators, they just see byte streams, and byte streams erase away the difference between these two things, which is why my sense is like we should probably just do the thing that makes the spec appropriately general and like reasonable to describe.
yeah, that makes sense to me. Yeah, so with that being said, I feel like we can keep the spec pretty general, and then I think the way I described it before uh would be okay. But when I have actual text, then we can go over it in detail. And then the question of what exactly GraphQL JS should return, I can kind of leave it up to the GraphQL JS maintainers and
Yeah.
do as they see fit. And
There is something that I'll just say part of the reason why I like the current type is like I could actually even imagine this first like execute a result or piece going away at some point in the future, and just saying like you're gonna get this sort of tuple of your initial execution result. And then, by the way, also, if you've included defers and streams, then this async generator over here is going to contain additional values. But that part of the reason why that is nice is it unifies the path where defer and stream exist in your operation and the path where they don't have the exact same like initial payload. I appreciate that's not actually how it works today because for historical reasons you want to keep the existing API. But you could have imagined like a separate top level function or something like that that's like GraphQL that supports defer and stream. And when you adopt that, it changes the return type to be this. Because it's weird that the return type differs by what's in the operation. Like that's probably wrong. And then the other thing that's nice about this is it guarantees you will always get at least one thing, which an async generator does not guarantee. An async generator may resolve with 0 things in it, which does not make sense in the context of incrementally delivered GraphQL. But again, that's an implementation detail. Like you could just say in GraphQL.js, there's this thing called a result stream, which always gives you at least one thing. And then we're done. And then it's like how you implement it is up to each language to do so.
So my main concern with this is for people who are implementing a GraphQL server or whatever, and not everyone uses like an off-the-shelf server. Quite a lot of people just roll their own because, I mean, at the end of the day, traditionally what GraphQL does is it returns you a JSON object, you stringify that and you send it over the wire and you're done. And I'm concerned that anyone who treats it like that or doesn't put sufficient awareness in place, if they were to be given an async iterator, then when they tried to like, that's something they already need to handle when it comes to like subscriptions, for example. But if they're given a map, they're like, oh, it's a map. I know how to deal with this. I'll JSON stringify it. And like, it's got this extra property inside of it. And also, if when you process that initial result, say you pop the initial result off, you stringify that, you start sending that over the wire, that causes an error to happen. You stop processing. You've now not processed the subsequent results stream. Whereas in the other case, you are either given a map which you stringify, and if an error happens, no bother, or you're given a stream which you start to process. And if the processing fails, then your language already handles that, like try catch or whatever. We'll call the finally in JavaScript, and there'll be similar things in other languages. But if you never reference it, it's going to sit there, and it might well have like database connections behind this. It might have other forms of streaming data behind it. And if the implementation never like actually references that and starts like unbottling it, uncorking it, and ultimately terminating it, that could lead to errors. And I haven't managed to think of an algorithm that I'm aware of in the JavaScript ecosystem that's like a common, popularly used algorithm where you're given a map and the map contains a stream within it. It feels very foot gunny to me.
Yeah, it's a good question if there's precedent for this. I don't know. It does also make sense to me though that you have this, or maybe a contrast point here that's interesting is how subscriptions work, right? Where you either successfully have your subscription connection live and then you're just waiting for the first payload, or not. And so there's this question of like, if you were wanting to mirror that as a long-lived HTTP connection, when do you send the response headers? Like, do you wait until the very first subscription comes back, or do you sort of acknowledge the fact that your connection was established correctly first and then wait for the first event to come back? Which is different from this, right? From this, I would expect response headers in HTTP lingo, response headers come back alongside the first result. Because it would be weird to say, like, you've 200 effectively connected to the server, and like now we're waiting for the actual data to come back. And oh, by the way, never mind, your request was wrong. So non 200, but we already sent the status code back. So it does make sense to me that like the initial result is a different kind of thing from the others. It's part of the reason why this TypeScript type is useful, is instead of saying you're going to get a stream of either going to be initial results or it's going to be subsequent results, which is also like a little bit weird because nothing about that type says that subsequent results can't come before initial results, or you can't have more than one initial result. And this the type that we have today does make that restriction, right? It says like you are going to get exactly one, not zero, not two initial results. Then you will get zero or more subsequent results after that in this stream, which seems accurate. It is then true that you have to like appropriately convert that into an HTTP stream or whatever other serialization we're using. But I'm less worried about that being a foot gun because that's not something that like every person, certainly not everyone who's consuming GraphQL needs to consider. And even everyone who's like setting up a GraphQL server also doesn't need to consider that. The only people who need to consider that are people who are like building the bridge between GraphQL and HTTP layer. And that feels like library code. It's totally fine in my opinion to say like, you know, if the maintainers of GraphQL HTTP forgot to consume the generator appropriately here and therefore created a memory leak for every single GraphQL service that uses that library, then we should be like rightfully frustrated with that and get it fixed. You know, if that bug magically manifests the day you upgrade from, you know, GraphQL JS version 16 to version 17, then that would be bad. So like making sure that you need to deal with this in a way where we don't just like latently create a memory leak seems important. But otherwise, I'm, you know, from a GraphQL JS point of view, using the more specific type, even if it's like slightly weird, seems like the right thing to me. And then from the spec point of view, trying to be as agnostic to this as possible seems like the right thing. Like if we want to just say it's a stream, by the way, there's a rule that says you will always get exactly one execution initial result followed by subsequent results. Great. Then that's like exactly in aligned with what this type is trying to do.
Yeah, I think from the spec point of view, we should definitely describe it as a stream because I can't think of a transport where you would return a map that contains a stream within it. All the transports are going to be like you get a payload or you get a stream of payloads, and that is it. So in my opinion, that's what, even though the spec doesn't care about your transport, it does care that you will have one. And so in my opinion, it should just return a stream.
And to be fair, even saying you'll get a map or you'll get a stream of maps is also actively wrong because only in like very strange, very specific cases do you ever actually get a map. You almost always get a promise or a task which resolves to a map. Or you could say you get a stream of that will always contain exactly one payload of a map, which is the same as a promise or a task. But like right now the spec reads as if it was synchronous. It is not synchronous. Like it is not 100% factual to say that calling execute operation gives you back a map because it eventually gives you back a map after doing all that's asynchronous stuff under the hood. And we were just like, asynchronous programming, that's implementation domain. We will describe, you know, ultimately what this manifests as. So I agree, like if in that case, we described it as like the spec said, here's a map, one property, which is your initial thing, and the other property is a stream of things. I agree. That would be super weird. I would not want us to do that in the spec. If that's like a GraphQL JS ism that helps us like describe the behavior that we do want to specify, which is you'll get exactly one initial result followed by 0 or more subsequent results, then like this GraphQL JS type captures that in its GraphQL JS way, fine. And then the spec doesn't have to, it'd be, I'm in favor of like current proposal for GraphQL JS implementation and then the generalized thing for the spec.
Awesome. Yeah, super helpful. And I just want to spend 30 seconds to say this other pull request spec edits for section 3. We diverged going back into editorial changes into the spec, and now that those have been merged, this is up to date with the reference for that. This is just a pretty short addition only to section 3, the type system, where we define what the directives are. It's targeting a integration branch, which hasn't had anything merged to it yet, so it's the same as main right now. And so if you guys have time to give that a review, that would be helpful, and we can get this merged into integration and move on to the next section. Matt, you had already approved it. There's been just a few minor changes since then, but yeah, that's it.
It's on my list to look at again.
Awesome.
Nice. My suggestion is to be decently liberal with merging things into the incremental integration branch, just because, you know, nothing about our process here needs to hold you back from doing that. So do it at your judgment.
I think the aim of that branch is, because it takes a lot of time to get people to review this whole massive pull request, if we break it up into pieces and have people approve them bit by bit, it'll be much easier to do that final merge.
Oh, totally.
exactly.
Yeah. I'm happy that we're doing that. Just to say, like, you know, if everyone broadly agrees that it's the right change, like, don't wait for me to merge it. Benji, you're welcome to kind of hold that process if you want. But if you feel like you've gotten the appropriate eyeballs that you want on it and you're like 95% sure it's the right thing, great, merge it into the integration branch. And then, you know, pop pull requests for the next things we're talking about. We'll ultimately have to review the whole ball of wax in the end, and we'll do that. So I appreciate the process that we've got going here, where we get to look at each piece independently as we work towards it. I'm appreciating that we're up at time, and we've got a
Don't
couple
worry,
other
I'll add
broader
them to
discussion
another one.
topics.
It's fine.
Cool. Awesome. All right, everybody, fantastic progress. We're getting very close to our next cut of the spec, with a lot of things up at the wire to land in. So I'm going to be busy the rest of today and the next couple of days getting all those polished up and merged. And thanks all for the discussion on the rest of the stuff. Super excited to see the progress. Thanks, y'all.
Thanks, everyone. Bye.